All right, ladies and gentlemen, welcome. You're going to take notes a little bit different today. You're going to take some video notes. So you should have your note sheet for systems and lab conservation of mass out in front of you. One of your responsibilities when you are taking video notes is that you are paying attention, you're pausing when you need to write something down, and that you go back and rewind if you didn't understand something. So, this video, we're going to talk about systems. And in science, a system is really simple. It's just anything that exchanges matter and heat. Okay, so the lava lamp is a system, right? There's a light bulb on the bottom that gives heat or energy, and there's matter on the inside that responds to that heat and energy. Okay, a cup of hot chocolate is a system. Okay, you put hot chocolate in there, and then you have some evaporation and steam that will come off of that system. Okay, so it's anything that has matter and then energy being exchanged. Okay, so we're going to look at some of those things today. There's two main types of systems that we're going to talk about. The first one's called an open system. Okay, and so an open system is really any system that freely exchanges energy and matter with the outside world. So it's a system where the energy and the matter in the system can freely go into the environment and come back. Okay, so the example we're going to use is a pot of boiling water. If I put this pot of boiling water on the stove, okay, when that water starts to boil and turn into steam, that steam is matter and that matter can leave the pot. Now, if I wanted to, keep the level of water up in the pot, could I put more water in? Yep, there's no cover. There's nothing stopping me from putting water in there. So I can add matter to the system. Matter can be added and matter can be taken away. Okay. Same thing with energy or heat. Heat and energy are the same thing. Okay. So right now, how's my pot warming up? It's sitting on a burner on the stove, right? So the stove top is heating the pot. It's adding energy to the system. Okay, that energy that's getting added to the pot gets added to the water and makes those molecules get all excited. Okay, but if I touch the side of that pot, it feels hot. That feeling, that hot feeling, that's energy getting added into the environment. It's kind of like when you start cooking in the kitchen, your kitchen starts to get a little bit warm, and sometimes in the summer it can get really warm. Okay, that energy that's being released out into the environment, okay, is that heat. So here we have energy being added and energy being released. So when you think open system, you need to think energy and matter can both come in and go out. Okay, that's an open system. What do you think the opposite's going to be? Hopefully you've said closed system. Okay, so here's a closed system. I have a similar type of picture here. We have a pot. This pot's sitting on a Bunsen or on a hot plate. Okay, but this pot is getting warmed up still. But what's on top of the pot now? A cover. Okay, and what does that cover do? That cover prevents this pot and the water in this pot from escaping. You can see a little bit of condensation right there, right? We talked about condensation. That's the water vapor trying to escape and it can't. It hits something and it cools down. So the water, the matter, can't leave this system. Okay, and the cover's on the top, so I can't just pour water right back into the system. I can't add any matter into the system because the cover's in my way. That makes this a closed system. A closed system is a system that does not allow matter to escape, but energy will still be exchanged. So even though matter can't leave or come back in, this energy, okay, is still being exchanged. So if I would again feel the outside of the pot, it would feel hot. Energy is coming off of the pot, it feels warm. Okay, but the pot's also getting energy from somewhere. It's getting heated up by the hot plate. So energy is still being exchanged, okay, but the matter is not being exchanged. That's what makes this a closed system. Okay, perfect open, perfect closed system. That's what we're looking at there. So let's look at some real life examples of these things. Where do we see these in the real world? Here's one. It's a thermos. Okay, maybe you've used one of these before when you've gone camping or gone somewhere cold outside in the winter. So the matter in this thermos might be the coffee or the soup. Okay, the energy is the heat from the coffee or the soup because it was hot when it got poured in. So I want you to think: would this be a closed system or an open system? Pause the video till you have an answer. You're right. It's a closed system. Why? Because the cover is on this thermos. The energy or I'm sorry, the matter cannot escape, and I can't put matter back in here right now. It's a completely closed system. It's still being heated from the inside. The heat's still staying in there. Okay. But the matter can't be come in or out. So that makes it a closed system. How about this next one? We think about like the ocean. Okay, just think about the ocean. The matter is the water molecules that are in the ocean. Okay, the energy is the heat from the sun that can heat up the ocean and cause evaporation. So is the ocean an open system or a closed system? Pause the video. All right, hopefully you said an open system, and you would be right because energy can enter the system from the sun, heating up the water. Matter can leave when it evaporates, when the water evaporates, and it can come back in from precipitation, so like rain or snow coming back in, or rivers running back off into the ocean, runoff. Okay, that would also make this an open system. Last one, the whole planet Earth, closed system or open system? Take your guess. Hopefully you said closed system. Now, this one's not an easy answer because you can make an argument that it's an open system too. It's a closed system though, because we still have energy coming in and out. The energy is the sunlight that comes in and heats the earth. It gives us solar energy. It allows our plants to grow. Okay. And then the matter is everything else on earth, including the gases in our atmosphere. In our atmosphere, and the gravity that holds our atmosphere in is so powerful that it doesn't allow extra gas molecules to float off into space. Okay, so it means that all of the matter on Earth stays on Earth. But there's a problem, right? Because when we say it's a closed system, we say matter can't come in and matter can't go out. Sure, the matter on Earth can't go out, but we have matter come in every day to our system in the form of asteroids, in the form of meteorites, in sort of those things. A lot of them get burned up in our atmosphere, but some of them do make it to Earth. Like there's a lot of craters, okay, all over Earth showing that we've had lots of meteors hit on Earth, and they hit every day. Okay, and that's stuff coming into the system. So sometimes it's not a perfect open system and it's not a perfect closed system. Make sure you have these notes and some of these drawings written down on your notes. You're going to need these as we keep moving forward. We're going to do some labs looking at law of conservation of mass, and I'm going to be asking you, is this a closed system or is this an open system? So be ready to answer that question.